In this tutorial, we'll look at multiplying and dividing fractions. In Algebra 2, they're better known as rational expressions. A rational expression is a quotient of two polynomials. Examples of rational expressions include the following. So you could have x on top, x on bottom, you could have x squared, you could have any combination of polynomials. Because rational expressions are ratios of polynomials, you can simplify them as you can any other fraction. Recall that to write a fraction in simplest form, you can divide out common factors in the numerator and denominator. When identifying values for which a rational expression is undefined, identify the values of the variable that make the original denominator equal to 0. Since you can't really cancel something that's undefined, you have to make sure that you specify what values x can't be so that you know that you can simplify. In the first example, we have 10 over 6, which we can simplify like we normally do. Simplify top and bottom, divide them both by 2, so I get 5 over 3. And x to the 8th over x to the 4th, x to the 8th is 4 bigger, and it's on top. So that is simplified, but then I have to go back to the original denominator here and check and see what value of x would make it 0. So I would divide by 6, and I get x4 equals 0. X has to be 0 in order to make that 0, so x cannot be 0 for 5x to the 4th over 3 to be the simplified expression. In letter B, we have 6 over 9. We can simplify that to 2 over 3. And then quantities are those things that are on top or on bottom of a fraction with plus or minus in them. So x minus 1 and x minus 1 are exactly the same, so we can cancel them out. And I'm left with x plus 2 on top and x plus 3 on bottom. Since x is added to 2 and x is added to 3 in the bottom, they're not multiplied, so I can't cancel out the x. Only if I'm multiplying by x can I cancel it. In this case, on the top, this is adding and this is adding, not multiplying, so I cannot cancel. Then I need to go back to the original denominator here and set each factor to 0. Well, the first factor, 9, if I set it to 0, there's no value of x, so I don't have to do that. But I do have to set x minus 1 equal to 0 and solve for x plus 1 plus 1. So if x were 1, 1 minus 1 would be 0 here, and 0 times anything would be 0. So I'm not allowed to have x equal to 1. And then I also need to set x plus 3 equal to 0. Subtract 3, and I get x equals negative 3. So if I were to plug in negative 3, this would become 0. Negative 3 plus 3 is 0. 0 times anything is 0. So my final answer is going to be 2 times x plus 2 over 3 times x plus 3 when x is not equal to 1 or negative 3. Because if they were equal to 1 or negative 3, then the fraction would be undefined and it wouldn't be simplifiable anyway. Let's go ahead and look at when we're multiplying and not just simplifying. We can cross cancel, or we can just multiply straight across, whatever is easiest. So on the first one, we'll just multiply straight across. 3 times 10 is 30. X to the 5th and x cubed make x to the 8th because they're at the same level. Y cubed and y to the 4th is y to the 7th. 2 times 9 is 18. X cubed and x squared make x to the 5th. Y to the 7th and y to the 5th make y to the 12th. Now we can go ahead and simplify top to bottom. So 30 over 18, divide them both by 6, and I get 5 over 3. And then x to the 8th and x to the 5th, x to the 8th is 3 bigger, so x cubed on top. And y to the 12th is bigger on bottom, so it's y to the 5th. And then we can go ahead and set our variables equal to 0. So in this case, everything is multiplied together. So x can't be 0 and y can't be 0. Because if either one of them is 0, then 0 times anything else is 0. So if I were to plug in 0 here, 2 times 0 is 0, and then times everything else is 0. And in letter B, we need to put in parentheses here because we have a minus sign on top of the fraction bar. So that becomes a quantity. Now we can go ahead and cancel out things that are exactly the same. So x minus 3 cancels with x minus 3. X plus 5 cancels with x plus 5. And I'm left with 4 over x plus 3. And then I have to find out what the undefines are. So x plus 5 equals 0, so I subtract 5. And then x plus 3 equals 0 minus 3. And then x minus 3 equals 0. So I have 4 over x plus 3 as long as x does not equal negative 5, negative 3, or positive 3. When we are dividing, we have to make sure that we take the reciprocal. So we start off with 5x to the 4th over 8x squared y squared. Division becomes multiplication of the reciprocal. So I get 8y to the 5th over 15. And then I can start simplifying. So 8 cancels with, let's do this, 8 cancels with 8. 5 goes into 15 3 times. So I have a 3 on the bottom and 1 on the top. And then I'll look at x to the 4th and x squared. It's x squared is 2 bigger on top. And y to the 5th over y squared is 3 bigger on top. And then in this case, we have everything multiplied. So all of these things are multiplied together. So therefore, x cannot be 0 and y cannot be 0. And this is my final answer. Do I need the 1 in front of the x squared? No. I can leave it off and I'd be perfectly fine. I could also have x squared y cubed over 3. That would be perfectly fine as well. In letter B, I'm going to write 4x squared, x plus 3, x minus 3, all over x minus 3 times x minus 1. First fraction stays the same. Second fraction changes to multiplication and by the reciprocal. So I move x minus 1 and x minus 4 on top. And I move 2x squared, x minus 4, x plus 2 on bottom. Then I can start looking for things that are the same. So I have x minus 1 here and x minus 1 here. They cancel. X minus 4 and x minus 4 cancel. And we have x minus 3 and x minus 3 cancel. I have x squared over x squared cancels out. And then 4 over 2 cancels to 1 and 2. So on the top, I still have 2 times x plus 3. And on the bottom, I have x plus 2. And then to find out what the undefines are, I need to go back to the original denominator. So all of these quantities, when it's multiplication, do not go back to division because this is not on bottom anymore. It's actually what I have in the box. So each one of those equal to 0. So x minus 3 equals 0. So add 3, x equals 3. And then I have x minus 1 equals 0, so plus 1, x equals 1. And then I have 2x squared, that's another one, so 2x squared equals 0. Divide by 2. X squared equals 0, so that means x equals 0. And x minus 4, so we have x minus 4 equals 0. Plus 4, x equals 4. And then our last is x plus 2 equals 0, minus 2, x equals negative 2. So if it asks for the undefines, you would say x cannot be equal to 0, 4, 1, -2, or 3. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is our simplified answer and the values that make it undefined. I know that says that assume they're all defined, but I just want you to see how to find them.